This is the installation instruction video for the electric start for the EU2000i Honda generator. This video is going to cover the electric start motor, gearbox, and linear actuator for the choke solenoid. It is going to be limited to the mechanical aspects. The electrical wiring and remote will be covered later. This is an EU2000i with the cowling removed from it. You can see the starter motor. It's an electric motor. Then inside this housing is a single stage planetary reduction gear, which goes to a bevel gear, which turns a right angle, goes inside and drives a drive hub, which locks into a sprag on the flywheel. The sprag on the flywheel is pretty straightforward. You'd remove the stock Honda nut from the flywheel and install the drive adapter that holds the sprag in place. This is the sprag that I'm using right now. The drive adapter simply screws into the sprag and then screws onto the end of the crankshaft. This portion attaches to the starter motor, which then engages into the sprag. This is one of the starter motors right here. The starter motor will disengage from the housing. It is a twist lock that locks it in place. On the kits that I will be sending out, there will be JB weld right behind the two tabs that lock onto it, and then there will be a worm drive clamp around it, because it's been my experience that after a couple hundred hours of vibration, sometimes the starter motor would disengage from the hub. This kit is not going to be a kit in the sense that any of my other kits were. This is going to be a kit more like a home-built airplane. It's going to be a lot more complicated, and there's a lot more work for the end installer to do. This is going to be pretty much a set of basic instructions and the key components. It will be up to the end user to do a tremendous amount of fabrication. The fabrication that requires any expensive equipment is already going to be done, but as far as shimming and so forth, that'll be up to the end user. If you look at the starter in here, you'll see that it's already got the JB weld and worm clamp around it to keep it from vibrating loose. Procedure is pretty straightforward. It just requires a lot of patience to get each step done. This is the recoil mechanism from the Honda EU2000. The first step will be to locate the center, and this whole stock is approximately 6 millimeters. You'll drill this hole to 5/16 inch all the way through. It'll come out the back. Then you'll need to take an arbor and enlarge the hole to approximately 14 millimeters, but only down about 13 to 14 millimeters. It will not go all the way through at that diameter, because this is shouldered on the inside. And as you can see, there are several layers of plastic and webbing, so you do not take out the last layer of plastic. Zoom that in a little bit. you will not take out the last layer of plastic that is at about the 14 millimeter diameter. Once you get the hole the size you need, you notice that there is a lip right where the cooling fins end. You'll need to take a large draw file and file across this area here until you have reduced this lip to where it is touching this surface. And you'll know when the file actually starts to make cuts into the surface here. The reason for this is that the clearance between this housing and the inverter unit is so tight that we have to take advantage of every little bit of room we can get, even this 2 millimeter lip. Remove that and the starter drive bolts just a little bit tighter. So once you've got this lined up, take the starter motor assembly and put it into the stock drive. The pull rope will come out at about the 10 o'clock position, and the starter motor can actually be lined up to where it comes out anywhere you want between about 11 o'clock and 2 o'clock position. If you are going to attempt to retain the fuel tank, it's my recommendation that you line the starter motor up to where it comes out at the 11 o'clock position. So this will require that you draw file it from the 7 o'clock to 2 o'clock position so that the mounting flange will allow the starter drive to sit down flush. You'll know that the system is sitting flush enough if you look at the bottom. The mounting bracket is flat against the recoil start, and the threads on the drive shaft end just before it gets to the plastic hub. At this point, you'll have to through bolt the starter housing to the recoil start from Honda. Once you get this bolted on, take the drive hub that is supplied and thread that on. Now, because Honda never intended for this to be done, the recoil start housings are not real consistent. Just make certain that the end of the shaft from the motor does not stick out past the drive hub. If it does, then that will touch the mounting stud from the sprag clutch. With this all together, you'll then be able to test it for power. The red wire will be positive. The green wire will be negative. Because I only have two hands, I'll have to turn the camera or set the camera down while I turn it on. I'm a little bit shaky, but you can see that it is spinning correctly. This drive gear will engage into this drive hub along with the sprags. The way the whole thing works is the drive gear catches on the sprags and turns the motor clockwise as you're looking at it from the end. Once the motor is started and running, centrifugal force will throw the sprags to the outside edge. And this motor, in the eco throttle mode, runs at approximately 20 to 2200 RPMs. I've got this set up at 1800 RPMs, and you'll be able to see that the sprags do disengage. So the sprags on this are set to disengage at 1800 RPMs, which is lower than the idle speed in eco mode of the EU2000i. So next, you would take a straight edge and put it across these screws, and you will notice that this center plastic stub that's stock from Honda sticks about 5 millimeters further out than the rest of the air shield on the starter assembly. So you'd put your drive adapter and your sprag clutch onto the end of the crank, and then put a straight edge right across the portions of the housing where the original stock recoil start bolted on. You then measure the depth of the starter clutch housing, and that'll give you a place to start at. If your starter clutch is too far recessed, the best way to do it is to put just a washer or two between the starter clutch and the adapter hub. So with the adapter hub sitting there, you put 1 or 2 washers, screw the adapter hub, or screw the sprag clutch back onto it. Once you think you've got it right, go ahead and put the starter housing in place with the sprag clutch attached to the end of the crank. When it starts to push in, you want it to just barely touch right here when it's solidly touching the end of that hub. When the hub is solidly touching and this is just barely touching, once this torques itself down, this will suddenly be barely touching also, so the alignment will be just right. Incidentally, if the shaft from the starter motor is sticking out through the drive hub slightly, take a file and file it off. Like I said, none of these recoil start housings are exactly the same, so you'll have to address that with a draw file. Once you get this with the right amount of gap, then go ahead and test your hub by putting power to it and make sure it cranks over the motor. Incidentally, I'll go ahead and show you this one. I've got a power switch for the radio right out here. And on my remote control, I've got it set up so that the top button starts it. And the bottom button stops it. As far as the choke assembly, this is the linear actuator that runs the choke, and as you can see, it's a very simple bracket, and the piece of metal to make the bracket out of is going to come with the linear actuator. But all it does is hooks in to a hole that I have drilled in the top of the choke lever, and the return is very simply a spring. So I've got a piece of 32,000 safety wire going from the linear actuator to the choke lever, and a return is done by a spring. One end of the return spring goes through a hole that is drilled right here into the cylinder head cover. Very straightforward and simple. I go ahead and start it again with the camera on the choke mechanism. The linear actuator for the choke, the wiring is very straightforward and simple. In order for the starter motor to rotate the direction you want, the short stub of red wire that is on it should be positive. The short stub of black wire that's on it will be ground. On the linear actuator for the choke, the blue wire will be connected to the black wire on the starter motor. The green wire will be connected to the red wire on the starter motor. So that way, the linear actuator for the choke will pull the choke shut as the starter motor is spinning. It will come with a standard Bosch 5-pin relay. Pin 85 and 86 are the coil sides of this relay. Pin 30, which is the pin that is turned perpendicular to pin 87A and 87, is going to be the common. So that's where 12 volts will go in. This will be 12 volts all the time. 87A is the normally closed position, and that's the center pin. You'll not be using that. Pin 87 is this one, and this is where the 12 volts will come out of the relay and hook to the linear actuator and to the starter motor. So when you put power to these two, it'll close the circuit between these two to activate your starter. The fuel tank is a whole nother issue. The fuel tanks, the way that I get them small enough to fit is put a lid on the fuel tank and hook a vacuum pump to the drain port and put a vacuum on it. I then start heating the back of the fuel tank, and I regulate the vacuum by opening and closing the vent on the fuel cap lid. I can then heat and apply heat exactly where I need it for the vacuum pump to suck the fuel tank shut. Obviously, if you heat the back is soft, the front is rigid. This one here is another one of the tanks that I ruined. I typically ruin at least 3 tanks before I get one right. My own advice is that because you're going to be using this in a fixed location, don't bother wasting your time shrinking the fuel tank down to fit. Just run it off of an external fuel tank. Otherwise, you will have as much gray hair as I do. On this one, you'll notice that it does have an external fuel tank hookup, small fuel filter, and it runs right into the fuel pump and from there into the carburetor, which allows me to mount the battery inside, the radio unit inside, and so forth. The radio and the electrical will be covered in a later video. This was simply a quick demonstration of how everything will fit together for the electric start. If you're interested in it, keep an eye on it. I am working on a different version of the drive hub that'll have more room to allow you to put it together with a little bit less headaches, but that should just about do it.